Hi everyone, welcome back to our channel. Today we are going to see an interesting concept, that is what is the behavior of an inductor when an DC input is given to an inductor. And I would like to say in one more way, why an inductor act like an short circuit with an input of DC supply? Let us try to know the reasons. This is a very good confusing question in electrical engineering and the remaining students of intermediate, and I would like to give an overall view the theoretical study. So first I will handle this problem with theoretical study, and I'm going to handle out the output with a MATLAB simulation. So this is the MATLAB simulation what I had performed to show that what is the behavior of an inductor under steady state. Okay, now let's go into the concept. Okay, so see here. So the first question is, what is the behavior of the inductor with DC input? So I had taken an inductor with a rating of 50 millihenry, and I am applying a voltage of 20 volts. I am having a resistor in series. The current starts flowing as I of t. Okay, and with positive polarity as well as negative polarity. The current also flows into the inductor with positive polarity and negative polarity, and voltage at the inductor is VL. Okay, so now when you apply the KVL, you can get it. So current is leaving. Okay, so this is plus. This is plus 20 is equal to. Let us try to consider the drop across the resistor is VR. Okay, so therefore you are going to get plus 20 VR plus VL. So that's how KVL is verified. But now we require what is the voltage across the inductor. The voltage across the inductor VL is equal to L into di by dt. So this is the behavior of the inductor under steady state condition. Here you can see here the current is constant. Let us try to assume the current is constant. Why? Because DC supply is given, automatically current is also an DC supply, which is nothing but the constant current is flowing. Okay, so VL is equal to L into d by dt. Let us assume that current is of some 1 ampere current is flowing in the inductor. So whenever 1 ampere current is flowing in the inductor, so differentiation of constant is equal to 0. Okay, so differentiation of constant is 0, where this di by dt we are going to call it as the rate of change of current. Okay, so di by dt we are going to call it as rate of change of current. The rate of change of current with the DC supply is 0. Okay, so in a DC supply is given with 20 volts, the rate of change of current is 0. Automatically this term will become 0. Therefore the voltage across the inductor VL is equal to 0 volts. The meaning here VL is equal to 0 volts indicates that the inductor will try to act like an short circuit, and it acts like a wire. Okay, so it acts like a short circuit, or the inductor will try to act like a wire and allows to get it fully charged, and our inductor gets fully charged. Whenever it is fully charged, it allows the maximum current to flow, and it acts like an short circuit. So that's why an inductor act like a short circuit wire when a DC input is given. Okay, so this is the case under the case of a steady state. So the steady state means, so this is at time t equal to 10 seconds. The supply is given after 10 seconds. What is the behavior of the inductor? So this how we can understand. Okay, so this what the behavior of an inductor. It inductor try to act like an short circuit and make it a fully, and it will be acting like a fully charged inductor after a time of 10 seconds. That's why this is the case of steady state analysis. That's why all the professors or all the books mention that inductor doesn't allow the sudden change in current. Okay, so here di by dt sudden change in current. So inductor do not allow sudden change in current. Okay, so this doesn't allow the sudden change in current. That's the initial condition. Okay, this is transient condition, but after steady state it will try to act like a short circuit, and this is the behavior of the inductor. Now the same I am going to validate with a MATLAB. Okay, so here you can see the simulation, why inductor act as a short circuit under steady state condition, the simulation. Okay, so let's try to see here. I had defined a voltage source with 20 volts and a resistor with 47 ohms and a resistor with 2000 ohm and a resistor with 500, and I have one more series 500 resistor, and I kept an 50 millihenry inductor. And what is the type of supply I'm going to give here is DC supply with a voltage of 20 volts, and I am constructing, and this is a loop 1 and this is an another loop. Okay, now I'm going to run the simulation. So already I had completed it. The input applied is how much now? 20. The current in this branch is how much? 28 amperes. Okay, so the current in this branch is 28 milliamperes. The current gets divided into this branch as 9.3 ampere. The current which flows in this branch is 18. Okay, so 18.6 plus 9.3, which is equal to 28 amperes. Our KVL is verified. Okay, but here you can see here the current will flow in the inductor. How much amount of current? So this current is called short circuit current. So this current will flow into the inductor, and inductor gets fully charged, and the voltage, I am connected an voltmeter. The voltage across the inductor is how much? 0. Since the voltage across the inductor is 0, then I can conclude that inductor is acting like an short circuit and allowing maximum current of 18.68 milliamperes of current to flow. That's why an inductor act like an short circuit under steady state condition. So voltage I applied, but this is the steady state current. The current is how much? 18.68. Then you can see this theoretical calculation. The current is 18.68 amperes of current will be flowing. Automatically the inductor will try to act like an short circuit. This is what the behavior of an inductor when an DC supply is given to the input, under which case steady state. But behavior of inductor under transient, just before switching, just after switching, and after steady state is entirely different. That I will discuss in one more video. Hope you are able to understand. Okay, so this is what the behavior of an inductor under steady state condition. It just act like an short circuit. Short circuit means it is getting fully charged. The inductor gets fully charged. The inductor gets fully charged with a current of 18.68 milliamperes, and the voltage here you see the voltage is 0. So what is the voltage we applied here? 20. In this voltage of 20, here the voltage of 19.38 and 19.3, totally here 2 volts will be dropped and remaining voltage will be available here, and this is nothing but 18 is nothing but 9 plus 9, which is nothing but 9 plus 9 is 18, and here you are going to have 18 plus 2 is once again 20. That's how the inductor act like an short circuit in steady state condition. What is the behavior of an inductor in transient state? We will discuss in another video. The behavior of the inductor is entirely different in transient state. This is nothing but just after switching, and the behavior of the inductor is entirely different just under steady state condition. This is nothing but at t equal to 10 seconds or t equal to infinity. Hope you are able to understand at least by this simulation. This is one of the toughest concept what we have in engineering, so people don't understand this. So thank you for watching. We'll meet in another beautiful video. So if you feel my explanation is good, to see more videos, to encourage me, just give an like to the video and share with your friends. And if you're watching my channel for the first time, subscribe to my channel. If you have any doubts, let me know in the comment section. And if you want to subscribe my channel, just you have a button here, just click on the button and subscribe my channel, and kindly encourage this sort of a free channel for the development of students and faculty. So thank you for watching. We'll meet in with another beautiful doubt. Yours Ram.